Hi everybody, welcome to the first video in Algebra, section P.1, algebraic expressions, mathematical models, and real numbers. Actually, we just studied about algebraic expression and real numbers. So first, algebraic expression, we just have to somehow define what is algebra. So algebra meaning we use a letter to represent numbers, loosely speaking. If a letter represents a various number, it is called a variable, meaning it will take various values, so that values can change. Therefore, it is called variable. A combination of variables, numbers, with the operation such as addition, subtraction, multiplication, division, power, and root all together is called an algebraic expression. So for example, this is what we have: a variable x minus 3, 2 minus x to the 5th plus 3x cubed. That's a algebraic expression. A square root of x plus 1 over x, that also an algebraic expression. And the other operation is just simple review. We do inside the parentheses first, and after that will be exponent, root, multiplication, division, and then addition, subtraction. So in the middle school, maybe you have something like please excuse my dear Aunt Sally. They don't have the root, but root is, in the sense, it's just like power. So please excuse my dear Aunt Sally. They don't have root, but root is just a form of power. We'll see that in the future sections. Right, I'll just have one simple example here. By the way, I post this note online. You can print them out, but if you don't want to print them out, you just need to write out the example of each section, because most of the problem we have is dealing with example. Right, now evaluate this when x equal to 6. So when doing that this, we can just put 6 into x and then evaluate. Let's do this by hand. Now x equal to 6, so we can replace 6 into x. And then order of operation. Inside the parentheses first, so we have 7 plus 5, 6 minus 4. This is the first thing we'll do. It's going to be 2. And now we do 2 square. So we have the parentheses and now the exponent, which is the square. So we do the square. And the 2 square is going to be 4. And that's still multiply. So we do multiply first and then add. That gives us 7 plus 20. We do this. And then 27. Well, on the calculator, if we have a calculator, there's a lot of ways to do this. We can just say we enter the number for x, for example. We have 6 store. This is the store into x. So now x is equal to 6 when we do that. Which is 7 plus x minus, where's the 5? X minus 4 square. You see, that also works. Or you can also do this. So x is just a variable. Anything that in place of x can be thought of as a variable. So I could use something else. For example, if I say 6 plus 0, of course. So what's the point of doing that? The reason I do plus 0, so when I hit second, the negative sign, second the negative sign gives us the answer. The answer meaning the last number that we have. Right? So once again, I do 6 plus 0. So now I know the answer is going to be equal to 6. So instead of using x, I can just say 7 plus, I forgot the 5 again. So instead of x, I use the answer, and the answer is the previous answer of the calculations, which is 6. So this, instead of x, it's going to be 6 here. That will come in handy later. Right. The next part is important. We need to know the set of real numbers. So real numbers, first the natural numbers is the counting number, and 1, 2, 3, 4, 5, and so on. And the symbol for that is look like the letter N. It's called the N, the double face N. So the way we write notation for that is we say it N equal to, and we have the bracket, which is list all the numbers in that set. So natural numbers is a set, which is the collection. We can list the values, can be 1, 2, 3, and so on. So we write in the curly bracket, denote that it is the collection or the set of the numbers from 1 and so on. So we just list like that. So the bracket is meaning a set. Right, next. The whole number denoted by W, also the boldface. By the way, if we want to write out the natural number, just say extra line like this. The whole number, just extra line. So it's not just a W. Alright, so the whole number, the difference between the natural numbers and the whole number is that we just have the number 0 in it. So the set will be the same as before, except the whole number, we're going to have the extra number 0 into it. So adding 0 to the natural numbers, we increase the set or increase the collection to the whole number. Right. Next, when we add all the integers, when we have all the negative to it, so we have 0, 1, 2, 3, and then all the negative 1, negative 2, negative 3. So here we have all the negative that. So we just have what we have before. But now we have the negative. For example, negative 2, negative 1, and then we have the 0, 1, 2, 3. Of course, we have dot, dot, dot on both sides. Dot, dot, dot. Right. So, natural numbers, counting numbers, 1, 2, 3, and so on. Adding 0 to it, make the whole number. Adding negative to it, give us the integers. The next one, kind of difficult to put in the set. We call the rational numbers. The rational numbers is can include all the fraction. Pretty much rational number include anything that can be written as a fraction. So I will write a definition. Rational numbers, meaning that anything can be written as a fraction. So here we have all the integers. We just divide by 1 will be itself. By divide by 1 we create fraction. So yes, all the integers are also fractions, right? Because negative 2, we can just say negative 2 divided by 1, it's just negative 2. So we say because negative 2 can be written as a fraction, it is called a rational number. It is also a rational number. So rational number include all of those integers, include all the fractions, all the terminated and repeated decimal. For example, 3 divided by 2 is 1.5. So we say 1.5 is rational numbers because it is written as 2 over 3, a fraction. Also, if we flip it, 2 over 3 is 0.666, or just say it, 0.6 repeating. Yeah, so 6 repeating. And so if it is repeating, it can be written as a fraction. If it is terminated, it does not go on forever, we can also write that as a fraction. So integers, fraction, terminated or repeated, decimal, all of those together are rational numbers. And irrational number, meaning that the number that is not a rational number. So meaning not rational numbers. And those are decimal representation that are neither terminating or repeating. Of course, we can write different way later in the next example, you'll see. And put the rational number and irrational number together, we have the real number. Right. Now talk about this symbol that we have here. Of course, natural numbers we use n, that makes sense. Whole number w also makes sense. So integers, of course, does not start with the letter z, right? So where's that come about? Actually, I look it up. The reason we use that symbol because that from the German word Zahlen, I don't know how, probably that's how it pronounced, means count or to pay, I think. And next, rational numbers, we use Q because in Italian, quotient, of course, that certainly look like quotient in English. So that makes sense. So that, of course, the quotient is something divided by something, which, of course, a ratio. So that's why the rational number, we use Q because that's like quotient. And Z is in German, mean count or to pay. Right. And then irrational numbers, they have no significant number to that. We just have, and then we have real numbers written in English, so start with the R, so that makes sense. So natural numbers and N, whole number W, Z, integers, Q, rational numbers, and we don't have anything for irrational, and then we have real numbers. Include everything, right? Now, to summarize, I'm going to put this in the set like this. So the natural numbers is very small, the smallest set. Include in that, just going to draw an ellipse. So natural numbers is very small set. For the bigger set, if you add 0 into it, we go to a bigger set. And we have the W, which is the whole number. Now we get to even a bigger set. And that gives us the integers. I'm just put different color with no color scheme at all. And then from bigger than integers, we have rational number. Right, and we're not going to get a bigger set than this. What we have is that it is completely this part that is outside of the rational number. This is called irrational number. Like I said, we can use I, but I just spelled out irrational. Irrational is not rational. And altogether is the set of real numbers. So real number is rational and irrational. Right. And with that, we go to the example. But before that, I just want to bring an interesting quote right here. Natural numbers were created by God. Everything else is the work of man. Right. So I elaborate. I this may or may not be the way Chronicle intended, but this is the way I understand it. So let's say God created the whole chicken or the whole egg, for example. God did not create half a chicken. We, the people, cut the chicken in half. So that's why I said 1/2 rational numbers is the work of man. That, I guess that's what he means by that. And also, on a more serious note, we start with the natural number 1, 2, 3, 4. Everything works out perfectly. We can add them. 2 plus 3 equal to 5, 4 plus 3 equal to 7. Natural number plus natural number is still natural number, right? Now the problem is where we subtract. Let's say if we have 3 and we subtract 4. When we subtract 3 minus 4, we have -1. And the -1 does not belong to this set. So in that case, we have to make the set bigger. 1, 2, 3, 4, 5 is not enough. The number is not enough to have all of those calculations. So in order to accommodate subtraction, we have to have all the negative. Right, next. Dividing 4 divided by 2 works perfectly. But then 1 divided by 2 is 1/2. Once again, if we divide using this number, even negative, we're going to have the bigger set. So we start with the very small numbers. The set of numbers 1, 2, 3, 4 cannot do subtraction, so have to make the set bigger. And then we cannot do division, have to make the set bigger. And then next, we take the square root. Square root of 4 is 2. That's perfectly fine. But then square root of 5 is 2 point something. That's all we know. But we use that. And you see this is a decimal number that is not terminated, nor repeating. So square root of 5 is irrational. So what we have is interesting. If I put a note here. So when we have square root of a number, when n is natural, square root of a natural number is either a natural number, like square root of 4 is 2, or if it is not a natural number, it will be irrational number. Right. Now let's go look at this example. Now we classify this number into the set. Remember, anything in natural number will belong to the bigger set and the bigger set and bigger set. Right. So let's look. -3. -3 cannot be counting number. Counting number doesn't have negative. Right. Also whole number doesn't have negative either. But -3 is an integer. If it is an integer, then that have to be a rational number. Because -3, we write divide by 1, that is a ratio, therefore a rational number. Right. If it is rational number, it cannot be a rational number because those two can be either irrational or irrational. So since it is rational already, it cannot be irrational. So -3 does not belong to irrational number. But it is going to be real. So we have the first number. Right, next. 2. 2 is the natural number. And if it is natural numbers, it have to be the whole number. It have to be integers. It have to be rational, like 2/1. If it is rational, it cannot be irrational, but it can be real. I said can be either rational or irrational. Right. Next, 0. 0, the counting number doesn't have 0, so we start from 0 is the whole number. Certainly integers. 0/1 also rational number. If it's rational, it cannot be irrational, but anything rational is going to be real. So we have that. Now 2 over 3, we talk about that. Obviously 2 over 3 is equal to 0.6, repeat the decimal, right? So actually we don't need 2 over 3, it is a fraction already. So it can be only be rational. Cannot be irrational because it already rational. But rational or irrational, it is going to be a real number. Right. Next, square root of 25. So what is square root of 25? Square root of 25 is 5. 5 times 5 is 25. So square root of 25 is 5. So square root of 25 because of that equal to 5, which is rational whole number. Just write square root of 25. Square root of 25. Also whole number. Also integers. Also rational. Cannot be irrational, but still real. Right. So that's why we notice this relation. Natural numbers inside whole number, inside integer, inside rational numbers. Irrational is completely different things. Right. 12 over 3. 12 divided by 3 is 12 divided by 3 is 4. And 4 just counting number, so a natural number. So we have 12 over 3. I'm just going to write like that. If it is natural number, it will be a whole number. If it is whole number, it will be integer. If it is integer, it will be irrational. If it is rational, it cannot be irrational, but still real. Right. Next we have 1.6 repeating decimal. Repeating decimal is a form of fraction. So this is easy. So we just say run out color here, so just go back. And this is repeating decimal, so this rational number because of repeating decimal. So rational number, sorry, 1. 1.6 repeating, it also be real number. Right. Square root of 3. Square root of 3. So that once again is not repeating nor terminated. So if we see, we have square root of natural numbers. If it is a natural number which is not square root of 3, it did not come out as a natural numbers. So in that case, it is going to be irrational number. So we have the first irrational number in here. But regardless, irrational number is still real. And then next we have pi. So pi is 3.14 and actually 3.14159. Okay. So again, not terminated, not repeating. So pi is also irrational, but that also real. And the last one is imaginary. We talk about that in the next section. So imaginary does not belong to any of this. Right. So that's how we classify some certain numbers into subset of real numbers. Right. And notice that once again, natural numbers inside the whole number, inside the integers, inside rational numbers. Irrational numbers is outside of that. But rational and irrational together is the set of real numbers. Right. Talking about real numbers, usually we can represent that by the number line, where we have 0 in the middle, positive on the right hand side, negative on the left hand side. Right. Because we may have and then negative on the other side. And decimal numbers will be in between, but all the real numbers will fill the line completely. Right. So every point on the number line can be represented as a real number. Right. Next, we have absolute values. Absolute values definition is the distance from a number to 0. So distance, because of that definition, it cannot be negative. So distance cannot be negative. It can be 0, but it cannot be negative. But then you say, why don't we have the negative in the definition? Well, now if we stick to the definition and write exactly like that, we'll see. I'll just do one example. Let's see what is absolute values of negative 3. According to this, if we have a negative number, absolute values is going to be opposite of that number, and for that turn to be a positive number. So here, this negative is actually not a negative. That means opposite to it. If it is negative, right? So if it is negative, we turn that to opposite. Of course, opposite of negative is positive. So that's why we have that formula. Right, as you see, and look at this, 1 minus square root of 2. We talk about square root of 2, which is 1.4 something. And we take 1 minus that. It's going to be negative, right? Because it's negative. If we want to write that, we say it. Because this is going to be a negative number, absolute values guarantee that if it's negative, it's going to be opposite. Right? Yeah, so that's how it works. Next, pi minus 3. We talk about pi, that is over there, 3.14 something. So that minus 3 is going to be positive. If it is positive, it will stay the same. Right? Pi is bigger than 3. Pi minus 3 is going to be positive. If it's positive, it will stay the same. Positive, stay the same. Negative, turn to opposite. Now, what is absolute value of x over x? Now, we have absolute value of x is equal to x if it's positive and equal to negative x if it's negative. Of course, I brought the condition. So what I write, I said, if x greater than 0, if x less than 0. Now, what I do is I can just divide by x on both sides of the equation. So we said absolute value of x over x is equal to 1 if x greater than or equal to 0 and negative 1 if x less than 0. I thought it's nice to bring up this example, but bottom line is in this section you should know how to classify real numbers. And with that, I finished section P1. See you in another video in Algebra. Thank you for watching.